Good afternoon, ladies and gentlemen. My name's Reardon, and I'm here to talk to you about capacitors and DC circuits. A capacitor is an electronic component made of a dielectric substance, sometimes referred to as an insulator. When a capacitor is charged with opposing charges, an electric field is produced between the two plates. The capacitor stores the capacitance-related charge thanks to its electric field. Contrary to a resistor, a capacitor stores energy as an electric field, preventing it from being dissipated. This energy is obtained from the equation W equals 1 over 2 CV squared, where W is the energy or work of the capacitor expressed in joules, the source voltage is V, while C is the capacitance. However, as soon as the source voltage is cut off, the energy that the capacitor has stored will start to leak back into the network. The capacity to retain an electrical charge across an electric field is known as capacitance. The formula C equals Q over V determines the capacitance, which is expressed in farads, where V is the voltage across the capacitor and Q is the capacitor's charge expressed in coulombs. The capacitance is inversely related to the distance between the plates and is also directly proportional to the permittivity of the material and the surface area of the conducting plate. A capacitor is said to be in a steady state when it's completely charged. At this time, the capacitor acts like an open circuit, carrying no current but producing the highest possible voltage. Now, it's crucial to keep in mind that capacitors behave in a way that is opposite to resistance when integrating them into DC circuits. The total capacitance when connected in a series is shown, and also when it is connected in parallel is shown also. It is important to note that a circuit is referred to be an RC circuit if it has just resistors and capacitors. In terms of time, often seconds, the temporal constant tau is expressed. The term tau refers to the result of resistance and capacitance. After 1 tau, the capacitor will have charged to around 63.2%, and after 5 tau, it will be fully charged. The following picture contains the formulas necessary to determine the stored energy while charging and discharging capacitors. The current starts at the highest level in the capacitor and slowly zeroes out when the voltage in the capacitor does the polar opposite. Here is a typical equation regarding capacitors and DC circuits. Calculating the time constant and formulating the relevant equations to calculate the circuit's voltage and current. Give it a go. The solution will be shown after. I appreciate your attention and I hope you learnt something. Thank you.